Hey everyone, Mr. Houck here. Just like with the 7.5 notes and the 7.5 homework, I wanted to go ahead and make a bonus video of me talking through the 7.6 homework since I'm not there in person to answer any questions. So that way, if you get stuck on any of the 7.6 homework problems, you can at least hear me talk about how I solve them. All right, so the 7.6 homework, starting off with number 1 here, it says let theta equal pi over 12. Write theta as a sum or difference of angles on the unit circle. So 3 pi over 12 minus 2 pi over 12 would give you 1 pi over 12. And 3 pi over 12 is pi over 4. 2 pi over 12 is pi over 6. So these two angles from the unit circle, if you subtract them, will give you pi over 12. Okay? So now find an exact value for the sine of theta. So we want to calculate the sine of pi over 12. So we used, to get pi over 12, we did pi over 4 minus pi over 6. So there's our alpha and beta. We apply the subtraction formula for sine. So sine of pi over 4 minus pi over 6 is going to be sine of pi over 4 times cosine pi over 6 minus sine pi over 6 times cosine pi over 4. Get your values from the unit circle. Remember, you have to have those memorized. And then multiply. Root 2 times root 3, that's root 6. 2 times 2, that's 4. 1 times root 2, that's root 2. 2 times 2, that's 4. And you can either leave your answer like this, or more commonly, you would combine it into a single fraction, since you have the common denominators of 4. All right, so that's number 1. Number 2, similar idea, different angle. Let theta equal 11 pi over 12. Well, 3 pi over 12 plus 8 pi over 12, that would give you 11 pi over 12. 3 pi over 12 is pi over 4 when you reduce it. 8 pi over 12 is 2 pi over 3. And these are both from the unit circle. So, same idea. We want to calculate the cosine of 11 pi over 12. We're using pi over 4 plus 2 pi over 3 to get 11 pi over 12. And then we simply follow cosine's addition formula. Remember, with cosine is the one you have to pay attention to. If you're doing cosine addition, you're actually going to have a subtraction sign in the middle. So cosine, those signs get switched. Sine, they stay the same. Cosine, they get switched. And here's what you end up getting. So pull your values from the unit circle. From the first two, you get negative root 2 over 4. Over here, you get root 6 over 4, but they're being subtracted. Because they are both negative, when you combine them, just make sure they both have the negatives with them. Okay? Negative root 2 minus root 6 over 4. Or you could have also said negative root 6 minus root 2 over 4. As long as you show them both to be negative, the root 6 and the root 2. All right? Number 3. This is us basically deriving the double angle formula for cosine. So it says, all right, take cosine of 2 theta, write 2 theta as addition. Well, 2 theta is theta plus theta. Then take the cosine addition formula using theta and theta for alpha and beta. So follow the formula. This is what we get. Cosine times cosine is cosine squared, so cosine squared of theta. Sine times sine, that's going to be sine squared of theta. So cosine squared of theta minus sine squared of theta. And that is one of the 3. It's that first one there for the cosine double angle. Okay, the other 2, these 2, you can actually take this one right here and you can use your Pythagorean identities to rewrite it. Okay, that's what you could do if you wanted to. All right, number 4. Solve the equation cosine of 2w plus 2 sine squared of w equals negative sine of w, where w is between 0 and 2 pi. So from number 3, we just saw that cosine of 2 theta is cosine squared theta minus sine squared theta. So we're going to replace this cosine of 2w with cosine squared of w minus sine of squared of w. So that's the first step. Use the double angle identity to replace. Now notice negative sine squared, so this is a negative 1 sine squared, this is a positive 2 sine squared. These two are like terms. These two would combine to give you positive 1 sine squared. So now we have cosine squared plus sine squared equals negative sine of w. Cosine squared plus sine squared is one of your Pythagorean identities from the previous set of notes. Those are equal to 1. So now we have 1 equals negative sine w. Then I just divided negative 1 on both sides. Now we have sine of w equals negative 1. And sine is negative 1 when the angle is 3 pi over 2. So the answer is w equals 3 pi over 2. All right, that's the front page. Second page. Find sine of alpha plus phi. This is the Greek letter phi, phi. Right, Greek letter phi. This is alpha. So sine of alpha plus phi, we just use our addition formula. Sine of alpha times cosine of phi plus sine of phi times cosine of alpha. Notice that we have these values. Notice that this is a unit circle. The radius is 1. That means this 0.75, notice that this is angle phi. Okay, this is angle phi. So this 0.75 is cosine of phi. This 0.66 is the sine of phi. And then here's angle alpha. So this negative 0.81 is the cosine of alpha. This 0.59 is the sine of alpha. So these give us all the values we need to plug in right here. Then you just plug them in, use your calculator, because this is calculator active right here, and you get negative 0.0921. All right, number 6. Okay, so this one, probably the most challenging one on here at first. If the sine of theta, so we don't know what theta is, the sine of theta plus pi over 3 equals root 6 over 4 plus root 2 over 4, then find the cosine of theta. So here's what I did. Take the sine of theta plus pi over 3, use the addition formula. Sine theta times cosine pi over 3 plus sine pi over 3 times cosine theta. Cosine of pi over 3 is 1/2. Sine of pi over 3 is root 3 over 2. Now we know from up above, one of these is supposed to give us root 6 over 4. One of these is supposed to give us root 2 over 4. Now, it turns out this one gives us the root 2 over 4. This one gives us the root 6 over 4. Okay? Just because root 3 over 2 bigger than 1/2. And to go from a 1/2 to a root 2 over 4, the other piece had to be a root 2 over 2. And to go from a root 3 over 2 to a root 6 over 4, this piece also had to be a root 2 over 2. So that means cosine of theta is equal to root 2 over 2, and that solves the problem. So a little bit mind-bendy, but that's how we handle that problem. All right, number 7. Which of the following will the graph of y equals 2 sine of x cosine of x look like? Well, this is a double angle identity. Sine of 2x is 2 sine of x cosine x. That's this one right here. Sine of 2 alpha is 2 sine of alpha cosine alpha. So if 2 sine of x cosine x is the same thing as sine of 2x, this is a horizontal shrink by a factor of 1/2 because it's multiplying inside. So that's answer choice D. All right, then finally, number 8. An angle of pi over 3 is on the unit circle. However, pi over 3 is also double pi over 6. Okay, so basically they want us to use a double angle formula to prove that sine of pi over 3 is square root of 3 over 2. We already know this because this is on the unit circle, but they want us to do a double angle to prove it. So we're going to take sine of pi over 3, we're going to rewrite it as 2 times pi over 6. So we're rewriting this as a double angle with pi over 6. Now you follow the double angle formula. Sine of 2 times an angle, so pi over 6 would count as our alpha, would be 2 times sine of alpha times cosine of alpha. Sine of pi over 6 is 1/2. That's going to cancel with the 2. 2 times 1/2 is 1. And all we're left with is the root 3 over 2. And then we've shown what they want us to show. All right. Hopefully me going over these homeworks has been helpful. I will catch y'all in the next one.